This is part 2 of kinetics and initial rate laws, determining the rate constant and the value and units of K. So what we have here is a more complicated experiment. This time we have two reactants that we're tracking. So what we're going to do is we're going to determine first the order of the ammonium concentration and then the order of the rate law according to the nitrite concentration. So what we have is rate equals the rate constant times the ammonium ion concentration raised to some power times the nitrite ion concentration also raised to some power. And we need to calculate N and M. So what we're going to do for the ammonium is we're going to find where the ammonium is changing but the nitrite ion concentration is remaining constant. So that's experiments 2 and 3. We always choose the larger value to go on top, so we're going to do rate 3 over rate 2. And that is equal to 5.40. I'm going to drop these sevenths because everything ends up being ratios, so I'm going to drop this times 10 to the negative 7th for calculating the rate laws. So we have 5.40 over 2.70 equals K, and we're going to do the larger one first, so we'll have 0.200 to the N times 0.010 to the M. We're going to divide by the second one, same value for K, and we're going to have 0.100 to the N and 0.010 to the M. Notice that our K's will cancel and that these will cancel. So what we're left with is this, which is 2, so there's 2, equals 0.2 divided by 0.1 is also 2 to the N power. Therefore, N has to equal 1. So now we know that this value here is 1. Let's go and do the same thing with the nitrite ion. This time we're going to compare experiments 2 and 1. So here we are varying the nitrite ion concentration where the ammonium ion concentration stays constant. So we're going to look at rate 2 compared to rate 1. And again, I'm dropping off this times 10 to the negative 7th because we're interested in the ratios. So we end up with 2.70 over 1.35 equals K. We're going to do the larger experiment first. So 0.100. We've already established that this is to the first power, so let's just go ahead and put that in. And then 0.010 for the nitrite ion concentration. And we need to figure out what M is. Remember, K stays the same, so it's the same K. 0.100 to the first, and this is 0.0050 to the M power. 2 divided by, or 2.7 divided by 1.35 is 2. These cancel out, so we have 0.01 divided by 0.005 is also 2. Therefore, M equals 1. So we have figured out that M here equals 1. Now we're going to find the value and the units of K. I'm going to choose experiment 2, but I just as easily could have chosen a different experiment. So I'm going to have rate equals K, ammonium to the first, nitrite ion to the first. So using experiment 2, I have 2.70 times 10 to the negative 7th. I do have to put this back in now. I'm going to change this molarity liters negative 1, or moles liters negative 1, to molarity because it makes the units easier to handle. So I'm going to have molarity, second negative 1, equals K 0.100 molar times 0.010 molar, since they are both to the first power. When you solve for K, you get K equals 2.7 times 10 to the negative 4th, molarity negative 1, second negative 1. Notice that we had to divide through by molarity and molarity again from here, so we ended up with molarity to the negative 1. So our final rate law in this case is rate equals 2.7 times 10 to the negative 4th, molarity to the negative 1, second negative 1, times the concentration of the ammonium ion to the first, and you don't need to put that 1 in, and then the nitrite ion also to the first.